this is a recap of our factoring polynomials notes. So when we're factoring a polynomial, meaning it has multiple terms, we are going to be taking out the greatest common factor from each term. So in this particular polynomial, each term is separated by the plus sign. So I have 3 terms. So we're going to look at each term, find the greatest factor between our coefficients, and then the smallest power of our variable factors. So on example A, I have between my coefficients 16 and negative 24. My greatest common factor there is going to be 8. And then between y squared and y, my smallest power is just y to the 1. So 8y is what I'm going to take out of each of those. So 8 times 2 is what gives me 16. Y times y is what gives me y squared. Then 8 times negative 3 is what gives me 24, and we factored out the y. So that was my greatest common factor. So 8y times 2y minus 3 is our factored answer. Okay. Again, on B, we're going to look for the greatest common factor between 12 and 28, and that is 4. X squared and x is just x. Y and y squared is just a y. So that leaves us here with 3x plus 7y. So in that case, 4xy was our GCF. On part C, I now have 3 terms I'm looking at. So between negative 8, negative 6, and 4, my greatest common factor there is 2. Now, I don't have an a in my third term, so I cannot factor out an a, but I do have at least one b in each term, so I can pull out a b. So negative 4a is what's left from that first term, minus 3ab from the second term, and 2 from our third term. Now on part D, this one looks a little different, but something our terms have in common here is this 3y minus 1. So that's actually considered a common factor. So I can factor out 3y minus 1, and for my first term I'm left with 5y squared, and on my second term I was left with that negative and the 6, so that's going to be negative 6. All right. Factoring by grouping. What I'm going to do here is group my first 2 terms and my second 2 terms, and with those 2 groups I'm going to take out the GCF. So 2x cubed plus 8x squared, I can take out a 2x squared, and that will leave me with x plus 4. So that's factoring the first group. Then my second group, I've got 3x plus 12, so I can factor out a 3, and that leaves us with x plus 4. And so similar to example D, I now have a common factor of x plus 4 that I can factor out. And on my first term, I'm left with 2x squared. And on my second term, I'm left with 3. All right, once again, I'm going to group my first 2 and my second 2 terms. Here my GCF is y squared. That leaves me with y plus 5. Here my GCF is 7. And again, that leaves me with y plus 5. So I have a common factor that I can pull out. So y plus 5, the first term leaves me with y squared. Second term leaves me with 7. Another case we have is when we have the difference of 2 perfect squares. So if I have a squared minus b squared, I can factor that as a minus b times a plus b. So the first thing we want to do on these is identify what our a and our b are. So on example G, what squared would give me 36a squared? And that would be 6a. Because if I were to square 6a, you have to square the 6 and the a, and that would give us the 36a squared. And then b, what would give me 25b squared? That would be 5b. So a minus b times a plus b. Again, on H, I'm going to identify my a and my b. A is going to be 2x, b is going to be 11y. A minus b times a plus b. Now I looks a little harder than it actually is. This is still difference of 2 squares. My a is simply 3x minus 1, and my b is x plus 6. So my factorization is going to be still a minus b times a plus b. There's just some more terms in our factoring here. So that was difference of squares. I can also have instances where I have the sum or difference of two perfect cubes. So when I have the sum of two cubes, again, we're going to have an a cubed and a b cubed. When I factor that, that's going to be a plus b times a squared minus ab plus b squared. And if I have the difference of two cubes, that's going to be a minus b times a squared plus ab plus b squared. So again, with these, the first thing you want to do is identify your a and your b. So on example J, what cubed would give me x cubed? That would be x. And what cubed gives us 8? That's 2. So there's my a and my b. And this is the sum of two cubes, so we're going to use this top factorization here. So a plus b times a squared minus ab plus b squared. And I apologize about that bell. On K, same story. We're going to identify our a and our b. So what cubed would give me 27y cubed? That's going to be 3y. And the cube root of 8 is 2. And this time I have the difference of two cubes, so we're going to use that bottom factoring. So 3y minus 2 times 9y squared, because that's a squared, plus 6y plus 4. All right, next one. Example L, we still need to identify a and b. So we need to find the cube root of 216x cubed, and that's actually going to be 6x. Then the cube root of 125y cubed is 5y. And this is difference again, so we're going to use that bottom factoring formula. So a minus b times a squared plus ab plus b squared. All right, so now some other instances, we kind of might have a hodgepodge of different things. The first thing you want to do in these instances is take out the GCF off the bat. So here on M, between 8x cubed and 64, I have a greatest common factor of 8. So I can pull that out. And now I notice inside I have a difference of cubes, where my a is x and my b is 2. So that a that we factored out has to stay in the front, and then I'm going to have x minus b times x squared plus our ab plus b squared. All right, again on n, GCF, I've got a 3y that I can pull out. So it leaves me with y cubed minus 8. And once again, I've got a difference of cubes here. This time my a is y and my b is 2. So that 3y we factored out stays in the front. And then we have a minus b times a squared plus ab plus b squared. All right, on O, we can factor out a 2xy, and that leaves us with x cubed plus 64. And this is a sum of two cubes where a is x and b is 4. So that 2xy stays in the front, and we get a plus b times a squared minus ab plus b squared. Now on P here, I have the sum of two squares, but the difference of two squares was when I got to use that convenient formula. And I don't have any common factors here, so this P can't be factored. Okay. And then last but not least, the area of a rectangle with width W is given by 32W minus W squared. So area is 32W minus W squared. So if we factor this expression, my common factor is W. That leaves me with 32 minus W. Now if you'll recall, the area for a rectangle is length times width. So if we were told that our width is W, that means that for length times width, this term 32 minus W is our length. So if I want to draw that, it's going to be W and 32 minus w.